You type hello to ChatGPT, 2 characters, 6 bytes. What actually reaches the neural network is not those letters, it's 2 integers, 9,906 and 13. That's it. That's the input. The English never enters the model. Every LLM you have ever talked to has been reading a sequence of numbers, not a sequence of words. Understanding that difference is understanding a lot of what LLMs get weirdly wrong. Last video, we scaled models until they wrote essays. This video, we finally look at the input side. Because if you don't know how your string becomes tokens, you don't know why the model sometimes miscounts letters, chokes on rare words, or bills you differently for English and Japanese. All of that comes from the tokenizer. And the tokenizer is a very old idea from Lecture 3, running live inside GPT. Quick reminder from Lecture 3, Byte-Pair Encoding, Sennrich, Haddow, Birch 2016. Start with all characters as separate tokens, then repeatedly merge the pair of tokens that appear next to each other most often in your training text. Do that 30 or 50,000 times. What you end up with is a vocabulary of common word parts. The becomes 1 token, ing becomes 1 token, unbelievable becomes unbelievable, roughly. Today's puzzle. If we already covered BPE in Lecture 3, why come back to it? Because BPE inside GPT is where a bunch of user-visible weirdness comes from. GPT can barely count the R's in strawberry. It bills English cheaply and Japanese expensively. It sometimes stumbles on capitalization. All of that is downstream of how the tokenizer chops your input. Look at the chops, and the model's behavior starts making sense. Today's 3 beats. First, a live tokenizer walkthrough. TikToken, OpenAI's tokenizer library. What real English text looks like after chopping. Second, special tokens. The little control plane tokens that tell the model this is the system prompt or the user's turn ended here, not part of English, but critical to how chat works. Third, the ways this bites you. Strawberries R's, multilingual pricing, numbers versus letters. Once you see it, you cannot unsee it. Beat 1. Live walkthrough. GPT-4 family models use a BPE tokenizer called Clone 100K base. Vocabulary of about 100,000 tokens. Let's take the sentence "the unbelievable strawberry milkshake." Feed it in. Output: the space unbelievable space straw berry space milk shake period 9 tokens. Notice the with capital T is its own token. Space un is its own token, different from just un. And strawberry does not exist as one token. It's straw plus berry. Look at the pattern. Common English chunks. The, believable, shake, each got their own token because they show up all over the training text. Rare or long words. Unbelievable, strawberry, milkshake got split into smaller pieces the tokenizer already knew. And note the leading spaces. In BPE for LLMs, the space is part of the following token. That's why space un and un are different. Most people find that weird the first time they see it. It's a real thing. One extreme example. The word internationalization. 20 letters. English speakers read it as one word. TikToken chops it into international plus ization, 2 tokens, whereas the word antidisestablishmentarianism gets chopped into idis, establishment, Aryan, ism, 5 tokens, same word length range, different chops, because establishment happens to be a whole word token that showed up a lot in training, and antidis's did not. Beat 2. Special tokens. Not every token corresponds to text. Some tokens are control signals the tokenizer inserts to help the model organize input. The most famous, the endoftext token, marks the end of a document during training. There's also imstart and imend for chat mode. The model uses those to tell when the system prompt ends and the user's message starts and where its own turn should end. This matters because the model doesn't have a natural notion of a user's turn. It just predicts the next token. If you didn't have special tokens marking the boundary between system, user, and assistant messages, the model would happily continue generating the USER's message instead of responding. Special tokens are the load-bearing scaffolding for chat mode, and they exist entirely because the tokenizer wraps them around your text before you ever see the model. One historical footnote. Early ChatGPT had a bug where a rare special token got exposed to users. The model, having never seen that token except as an internal control signal, would hallucinate wildly if you fed it in via clever prompt. This is now called the solid gold Magikarp problem after the specific token name. Fun example of why the tokenizer's private vocabulary should stay private. Beat 3. The gotchas. Strawberry. The classic. GPT often reports 2 R's in strawberry when there are 3. Why? Because to GPT, the word is not strawberry as 10 letters. It's straw plus berry. 2 chunks. It never sees the individual letters. It sees 2 tokens. Counting letters requires it to reason about the spelling of tokens it only has as opaque integers. That's a genuinely hard task for the architecture. It's not a bug in reasoning. It's a mismatch with the input. Multilingual pricing. English words are 1 to 2 tokens each. Japanese characters are 3 to 5 tokens each. Because TikToken was trained on mostly English text, so Japanese gets encoded with byte-level fallbacks, which are much longer per character, meaning the same paragraph in Japanese costs your API bill about 5 times more than in English. This is why open-source models like Llama and Qwen retrain the tokenizer for their target languages. Not a small detail. A pricing detail. Numbers, code, and rare Unicode. 1234 might be 1 token 1234 or 4 tokens 11, 2, 3, 4, depending on the tokenizer, which is why GPT is sometimes weirdly good at 3-digit arithmetic and weirdly bad at 7-digit arithmetic. Emoji tend to be 1 token each. Code often tokenizes well because it repeats. Every one of these behaviors is downstream of the vocabulary the tokenizer built. Not the model's intelligence, the tokenizer's memory. 3 takeaways before the quiz. 1. The English never enters the model. GPT reads a sequence of integer token IDs. TikToken with the clone 100K base vocabulary is the BPE tokenizer that does the chopping. Common word parts are single tokens. Rare words are split. 2. Special tokens like imstart, imend, and endoftext are control signals inserted by the tokenizer. They're not English, but they make chat mode work. Never expose them to users. 3. Most weird GPT behavior is tokenizer behavior. Strawberries R's Japanese pricing. Number miscounts. The model sees chunks, not letters. Fix the mismatch or route around it. Quiz 1. What does a GPT family model receive as input? A UTF-8 byte stream directly. B. A sequence of integer token IDs produced by a BPE tokenizer like TikToken. C. 1 hot vectors of English words. Or D. Phonetic transcriptions of the text. B. Hello becomes 9,906 followed by 13, 2 integers. The English never enters the network. TikToken with clone 100K base is the standard vocabulary for GPT-4 family models, about 100,000 tokens. Quiz 2. Why does GPT often say strawberry has 2 R's when it actually has 3? A. The model is stupid at spelling. B. The word tokenizes into straw plus berry. The model never sees the individual letters, only 2 opaque chunks. C. It's a training bug OpenAI hasn't fixed. Or D. It's counting only capital R's. B. This is not a reasoning bug. It's an input mismatch. Counting letters requires access to spelling, but the model only has token IDs. Straw plus berry. 2 chunks. To count R's, it has to reason about characters it never actually saw. Genuinely hard. Quiz 3. Why does the same text cost more in Japanese than in English via the OpenAI API? A. OpenAI charges more for non-English content. B. The BPE vocabulary was trained on mostly English text, so Japanese characters fall back to multi-token byte encodings, often 3 to 5 times more tokens per character. C. Japanese is harder to translate. Or D. Japanese servers cost more to run. B. This is a real structural bias in the tokenizer, not a policy decision. Open source projects like Llama and Qwen retrain the tokenizer with more coverage for their target languages to fix this. It's a genuine equity issue in the API pricing model. Back to the puzzle. The English never enters the model. Tokens do. The tokenizer is a small, ancient, unglamorous piece of the stack that shapes what the model is even capable of thinking about. That's why we revisited BPE from Lecture 3 inside GPT. Next video, recap of Lecture 6, all 10 videos in one arc. And then Lecture 7 starts the core NLP tasks. Next time, Lecture 6 closer, 10 videos in one arc, from the 90-second neural network to ChatGPT. And a look at where Lecture 7 takes us. Core NLP tasks, translation, sentiment, named entities, question answering, all powered by what we just built. Hit subscribe.